Hi everyone. Today we'll see the sinusoidal response or AC, a response of series RC circuit when the sinusoidal voltage of V cos omega t plus theta is applied through the switch S to the RC series circuit. What is the current response? That we'll find it out. When the switch S is closed at t is equal 0, this will become closed so that it will form a loop and we need to find out this I of t. The sinusoidal voltage V cos omega t plus theta is applied to this RC circuit. In this, V is nothing but amplitude, theta is nothing but phase angle. By applying KVL to this loop, the source voltage is equal to drops across this resistor and capacitor. Sum of the drop across this resistor and capacitor. So V cos omega t plus theta is equal to R into I plus 1 by C. What is the voltage across capacitance? 1 by C integral I into dt. 1 by C integral I into dt. So by differentiating on both sides, because I like to get this equation in terms of differential equation, by differentiating on both sides, R into di by dt plus differentiation of integral will become only I. That is nothing but I by C is equal to differentiation of cos omega t is nothing but sin omega t plus theta minus sin omega t plus theta, and coefficient of t will come out of that, that is v omega minus v omega into sin omega t plus theta. By rewriting this equation, by dividing on both sides with r, di by dt plus 1 by rc into I is equal to minus v omega by r into sin omega t plus theta. By writing this as a characteristic equation, by assuming d is equal d by dt, capital D is equal di by dt, d by dt, d plus 1 by rc of I is equal to minus v omega by r into sin omega t plus theta. This is your second equation. Out of this, because right side is not 0, that's why you'll have both complementary and particular function. So the complementary function IC is equal to C into e power minus t by RC, because e power minus pt, p is nothing but coefficient of I. Coefficient of I is nothing but 1 by RC. We have seen in the previous derivations. So IC is equal to C into e power minus p into t, p is equal to 1 by RC minus t by RC. This is your complementary solution. We have one arbitrary constant, this will find it out later. So to find out the particular solution, I am assuming this equation, IP equation, with this undetermined coefficients a and b. So IP is equal to a cos omega t plus theta plus b sin omega t plus theta. In the first equation, if you see, we have di by dt also. To find out the particular equation or particular solution, I'll use the same first equation with the IP here. So I need to get the dip by dt also. That's why I'm differentiating this fourth equation, that is IP equation. Dip by dt, p by dt, which is equal to ip dash is equal to, by differentiating this, differentiation of cos is nothing but minus sine, coefficient of t will come out, that is nothing but minus a omega into sin omega t plus theta plus b omega cos omega t plus theta. Differentiation of sine is nothing but cos, coefficient of t will come out. I'll substitute this fourth and fifth equation in the first equation by assuming I is nothing but IP. So I'm finding out the particular solution. So what is that? Dip by dt, which is nothing but this one, minus a omega sin omega t plus theta plus b omega cos omega t plus theta plus 1 by rc into ip. Ip is nothing but again a cos omega t plus theta plus b sin omega t plus theta, which is equal to, on the right side we have minus v omega by r into sin omega t plus theta. But take here, if you see the sine and cosine terms are there, coefficient of sine and coefficient of cosine terms, I will take it common. So coefficient of sine terms are nothing but minus a omega plus b by rc of sin omega t plus theta. Sine terms coefficients are common by minus a omega plus b by rc. Cosine term coefficients are b omega plus a by rc of cos omega t plus theta, which is equal to right side same term, that is minus v omega by r into sin omega t plus theta. Comparing on both sides, sine coefficients and cosine coefficients, sine coefficient is 0, cosine coefficient is 0 on the right side. So What is the cosine coefficient? B omega plus A by RC is equal to 0. And what is the sine coefficient? On the left side, minus A omega plus B by RC. On the right side, minus V by R. By solving this above equation, like in the previous derivation, like in the series series RL circuit we have seen, just simply you can do that. You can get this A in terms of B by taking this B omega on the right side. A in terms of B, you will get it. The A value you can substitute in this equation to have only B unknown coefficient. You will get the B again, the obtained B you can substitute in that A equation, so that you will get the A as VR by VR by R square plus 1 by omega C square, and B is equal to minus V by omega C into R square plus 1 by omega C square. By substituting this A and B values, so in the particular equation, this is solution 4, equation 4, IP is equal to A and B values. I am substituting in this equation. I will get VR by R square plus 1 by omega C square into cos omega t plus theta, as we have minus here, minus V by omega C into R square plus 1 by omega C square into sin omega t plus theta. By assuming this cosine coefficient and sine coefficients as m cos pi and m sin pi, I'll further simplify like this. So by assuming that m cos pi cos omega t plus theta minus m sin pi sin omega t plus theta. So cos A, this I am assuming A, this I am assuming B. So cos A cos minus B, or if you take this cos A cos B minus sin A sin B. Cos A cos B minus sin A sin B is nothing but cos of A plus B. So m of cos omega t plus theta plus pi A plus B. To find out this pi value and to find out this m value, I'll use these equations. What we have assumed, m cos pi is equal VR by R square plus 1 by omega C square, and m sin pi is equal V by omega C of R square plus 1 by omega C square. To find out that m and pi values, I'll divide one equation over the other. Then I'll get the tan pi is equal to 1 by omega CR, because these two terms are common, V and V common, 1 by omega C into R, I'll get it. Tan pi is equal to, where pi is equal to, out of this, pi is equal to tan inverse of 1 by omega C into R. And to get that m value, I'll square these equations on both sides, so that I'll get m square cos square pi plus m square sin square pi on the left side, and squaring of these two terms and adding, I'll get this v square r square by r square plus 1 by omega C square of whole square. And second term is v square by omega C square, v square by omega C square is divided by r square plus 1 by omega C square of whole square. So if we take this left side, cos square pi plus sin square pi is equal to 1, by taking this m square common, so that I'll get m square is m square of 1. On the right side, you'll get only single term, because r square plus 1 by omega C square, by taking this v square common, the denominator one term will get cancelled, so you have only in the denominator r square plus 1 by omega C square. If you want to get the m, means m is equal to, the square will go on the other side and will become square root. Square root of v square is nothing but v, and square root of r square plus 1 by omega C square. The particular current becomes, now by substituting this m and pi values, IP is equal to V by I am substituting this m value, m cos omega t plus pi. This pi and m value I am substituting here by knowing that. So IP is equal to V by under root of r square plus 1 by omega C square cos of omega t plus theta plus tan inverse of 1 by omega C into R. Now I got the complete solution for the current. I is equal to IC plus IP. IC already I got it with the arbitrary constant C into e power minus t by RC, plus IP I am substituting same IP I have written here. In this, only one arbitrary constant C is there. By knowing the initial conditions, we can find out that C also. Since the capacitor does not allow the sudden changes in voltage, what is the capacitor property? It does not allow the sudden change in voltage. At t is equal 0, whatever the voltage is there, or you see here, at t is equal 0, whatever the voltage is there, the same voltage will be there. At t is equal 0 minus, when the switch is open, the current flowing through this loop is 0 because this is open circuit. What is the voltage across this capacitance? Voltage across capacitance also, if you see, this is open circuit. Voltage across capacitance here also open circuit. So but out of this we need only current value. That's why I'm using that current equation. When the switch is open at t is equal 0 minus, current is 0. At t is equal 0 also, the current is 0 only. The same current will carry even if you use the capacitor voltage also. Capacitor voltage is 0 at t is equal 0 minus 0 by, again the loop equation, if you use 0 current only, you'll get it. So since the capacitor does not allow the sudden change in voltage, out of this I'll use both together. At t is equal to 0 minus, current is 0, voltage across capacitance. What is the voltage across capacitance? This is voltage. Voltage across capacitance, this is open circuit. So out of this, voltage across capacitance is nothing but source voltage, V cos omega t plus theta, right? T is equal to 0 minus, that is equal to 0. So V cos theta. V cos theta. At t is equal to 0 also, the capacitor does not allow the sudden change in voltage. So V cos theta. And at t is equal to 0 plus also, Vc is equal to V cos theta only. What about current? At t is equal to 0, the switch is closed. When the switch is closed and you have the capacitor in transient, capacitor will get short circuit. When the capacitor is getting short circuit, so in transient, capacitor will get short circuit. When it becomes short circuit, what is the current? I is equal to V cos omega into t. T is nothing but 0, or 0 plus means that is 0 only. V cos theta by R. So I is equal to V cos theta by R. That is nothing but V by R into cos theta. So V by R into cos theta. So I is equal to V by R into cos theta on the left side at transient, which is equal to C into e power 0 plus V by under root of R square plus the same term I'll use it. So what is C means? C is equal to V by R into cos theta. We're taking this term on the other side, V by under root of R square plus 1 by omega C square. I'm substituting the t is equal to omega t is equal to 0. So you'll get the remaining terms. This I'm substituting in the further equation. If I substitute the same thing in the complete solution, I'll get the complete solution as e power minus t by RC into the C coefficients, what we got it, plus the particular solution. So this is your complete solution. This is all about the series RC circuit AC response. Thank you all.